Welcome to the third and final video about parallel lines that are cut by a transversal. First, let's do a quick review of the relationships that we have learned in the previous two videos. First, we talked about alternate exterior angles and the fact that those angle relationships are congruent. Then we talked about alternate interior angles and how those measures are also congruent. And finally, it was consecutive interior angles whose relationship was supplementary. So let me just color code these and we'll take a look at a few of them as a quick review. Alternate exterior, angle 1 is congruent to angle 7, and angle 2 is congruent to angle 8. Remember, we talked about using these tick marks or a certain number of these arcs for recognizing or labeling congruent angles. So now I have the colors, but then I'm also going to be using those number of arches. So the second one, alternate interior angles are congruent. So angle 4 is congruent to angle 6, and angle 3 is congruent to angle 5. Okay, that's by alternate interior, they are congruent. And then last, the consecutive interior is right here, and so angle 3 and 6 add to equal 180. Angles 4 and 5 add to equal 180 because they are next to each other, consecutive interior angles. So those are the three relationships that we talked about in the previous two videos. The new relationship in this video, the first of two, is actually not new at all. You guys have learned about vertical angles in a previous lesson. Remember that those are opposite angles. They are across from each other from two intersecting lines, and they are also congruent. So opposite angles, they're congruent. I'm going to go ahead and once again use the arches and some color to signify, label which ones in this diagram are actually congruent. So angle 2 and angle 4 are congruent to each other, and angle 1 and angle 3 are congruent to each other. Skipping down to angles 5 through 8, angle 6 and angle 8 are congruent, and angle 5 and angle 7 are congruent. And again, this congruent relationship will allow me to find missing values by setting the two things equal to each other, because that's what it means to be congruent. They have equal measure. The second relationship is, and final relationship really, from these parallel lines cut by a transversal are corresponding angles. And corresponding angles are pairs of angles on the same side of the parallel lines and transversals. So we're on the same side of the parallel lines and the transversals, both of those places. So if we go to mark up this diagram, 2 is in the same corresponding position as angle 6 because they're both on the top of their parallel line and to the right of the transversal. So they're on top of their parallel line and to the right of that transversal. They are corresponding. So 1 and 5 are also corresponding because they are on top and both onto the left of the transversal. And then hopefully this kind of looks pretty familiar here. Then angle 3 and angle 7 will be the same, and angle 4 and angle 8 will be corresponding angles. Also, they are in the same spot. Those last four that I just talked about, 3 and 7, are on the bottom, so not on the exterior, they're not both on the interior. One is on the inside and one's on the outside, but they're both below their parallel line at that intersection. And they're both on the right-hand side of that transversal, and 4 and 8 are both below, but are on the left side of the transversal. Ultimately, the best way to kind of think about this is to think matching. Which angles are in the matching locations? So angle 2 is in the top right of this intersection. Angle 6 is in the top right of that intersection. They match. Their locations are in the same spot, and that they're congruent. So that's how we're going to use that information to again find missing values for X or missing angle measures or whatever. So let's go ahead and take a look at a couple problems. Just like in the previous videos, if you are asked to find a value of X or a missing angle measure, you want to first figure out like what is that relationship? Where is this angle in relation to this one? And in the previous videos, we were focusing on exterior them both being on the outside or them both being on the inside, and again, either alternate or same side of the transversal. But in this case, we have one on the exterior and one on the interior. But luckily, they are both in that matching spot. They're both in the top right of each of their intersections. So this means that they are corresponding angles, which means that they are congruent. So corresponding angles are congruent allows me to set up this equation. 3x minus 11 equals 139. I can go through and solve. So for this problem, it looks like x equals 50. Another example here, the parallel lines are going in a sloped position. We've seen this before where the transversal is then going horizontal. But the fact is that the 12x and the 15x minus 39 are in matching corresponding locations, both on the bottom right-hand side of their intersections. So they are corresponding, which means they are congruent, and I can set them equal to each other to solve. So after dividing both sides by -3, x equals 13 for this problem. So here they all are, the angle relationships that were talked about from these video lessons. And the big one here is consecutive interior is going to stick out like a sore thumb because these are the only ones that we mentioned that were supplementary, but it is important because it can help you find missing angle measures. The alternate exterior angles and the alternate interior angles are labeled congruent as such, but then that ultimately gives us this vertical and corresponding angle. Like this is it. Let me just highlight this because this is the one. This is the one that sums it all up. Yes, vertical and corresponding is in here, but just like in the last slide where I was showing you, like this matches with this one, or sorry, this double blue matches with this double blue by alternate exterior, red to red, red to red by alternate exterior. This is it, and this is going to be what we're going to be using so much of when we get to problems like in the next example. All right, here we go. We got a lot going on here. One thing I do want to point out before we get real far with all the numbers everywhere is that we have a lot of lines here, but the only ones that are actually labeled with the parallel arrows are these two horizontal lines. So though it might look like these negative sloped, these downward lines could be parallel, they're not marked as such, so we cannot make that assumption. So I'm just going to assume that these are my parallel lines, and I've got a couple transversals going on here to help us out. So I'm just going to try to do this in whatever order I can. So I'm going to start in where it's like angle 1, 2, and 3 and see what I can figure out from here. So if we look at the 70, vertical angles tell me that angle 2 here is also 70 degrees. And then by a linear pair, that means that angle 3 and actually angle 1, both of those, because they're a linear pair, they add up to 180 degrees. That tells me that angle 1 and angle 3 are going to be 110 degrees, and that should make sense that they're matching because of vertical angles. Now, I could jump over to this set of angle relationships over here, but I'm actually going to jump down because these are my parallel lines, but this is the transversal here. So I'm going to see what I can do with this information to help label down here. Now, I've got a couple different angles than I did up here, but if you look at the 70 degrees, that is in a corresponding place with angle 11. So angle 11 is also going to be 70 degrees. And by vertical angles and also corresponding angles, that means that angle 9 is also going to be 70 degrees. So I will at least be able to get that. Let's take a look if there's anything from the 110. So the 110 degrees would match here, but I don't know, there's too much missing information here. And same thing with the 110, it matches up with the 7 and the 8, but I don't have enough information right now just from the parallel lines cut by the transversal. I do know another tool we can use, but let's see what else we can figure out first. So let me jump over here to angles 4, 5, and 6. So angle 5 is vertical to the 70 degree here. So I'm going to label that 5 with 70 degrees. And then because this is not a linear pair, but these three angles are creating a line, and the 70 and the 50 is 120. So I know that angle 6 is going to be 60 degrees. And again, that's to get them all to add up to be 180. And same thing on the top. This is a linear pair that it's going to be the same 110 like the angles 1 and 3. Okay, so moving forward, now we do have a couple more options, but I'm actually going to come back down here to 7, 8, 9, and 10, and I can actually use this angle relationship up here because this is still two parallel lines, but now I can look at this transversal. So based on this transversal, it looks like angle 8 is corresponding to angle 5, so I'm going to make that 70 degrees also. And then we are then able to do a couple of different things. A linear set is right there, but then also what I really wanted to point out with this example is this 110 angle 4 does actually correspond to this pair of angles, angle 7 and 11. Since I know that angle 11 is 70 degrees, I can use that and the 110 to figure out what angle 7 is, but we can also do the linear set too. So we have our options here with our angle relationships. This ends up being 40. Oops. This ends up being 40 degrees for angle 7. And if I wanted to, I guess I'll go ahead and label it. It's not numbered, but down here would also be 40 degrees. And finishing this out, vertical to angle 8 is angle 10, which means that that is also 70 degrees since it is vertical to angle 8. And now it looks like all I have to worry about is this 12, 13, 14, 15 over here. So two parallel lines cut by a bunch of transversals. I cannot use any of this over here because their only connection is that they are all on the same parallel line. I need to use this top group to help me down here because this is the transversal that they're on. But even with the way this transversal stops does set its own set of challenges here. So looking at this, the only one that I can really use is angle 6 is corresponding to angle 14. Parallel lines, this transversal, they're both in the bottom right-hand corner. So that corresponding tells me that this 14 is also 60 degrees. And then vertical gives me that angle 12 is also 60 degrees. And then using the linear pairs and vertical, essentially, is that these two final angles are 120 degrees each. So that was a lot there. We had a lot of missing angles, a lot of transversals going on. I don't see myself giving you anything this complicated, but I just want you to see that how many different times the relationships show up and how we can use them in a rather challenging setup. So thanks for watching. Make sure that you reach out if you guys have any questions.